Hi everybody, this is Nageswara, Assistant Professor of Physics, SRR and Xavier Government Degree College, Vijayawada. Today we will discuss about mesh current method as a part of network theorems. Before discussing about the mesh current method, we want to remember Kirchhoff laws. We know there are two Kirchhoff laws. One is called Kirchhoff currents law and the second one is Kirchhoff voltage law. Kirchhoff currents law is also called Kirchhoff First Law. It states that the algebraic sum of the currents at a junction is zero, or the sum of the currents which is entering into the junction is equal to sum of the currents leaving from the junction. The importance of this Kirchhoff First Law is how much current is passing through the component at a junction. For example, in our houses, we are using socket. From the single socket, we are connecting TV connection, cell phone charger, and iron box also. How much current which is passing through the cell phone charger can be measured or can be calculated by using this Kirchhoff First Law. So when we have taken a junction like this, in which there is two currents are entering into the junction, maybe one is from the source of transformer and second one is from the battery. But from the same junction, we are connecting the three outputs. One is maybe iron box, second may be TV, and the third may be cell phone charger. In this case, the sum of the currents entering the junction, that is I1 and I2. That is I1 plus I2 is equal to sum of the currents leaving from the junction, that is I3 plus I4 plus I5. So that I1 plus I2 is equal to I3 plus I4 plus I5. So this is the application of the Kirchhoff First Law. What is Kirchhoff Second Law? Kirchhoff Second Law is used in a closed circuits. How much current is passing through the closed circuit can be calculated by using the Kirchhoff Second Law. Here we will use voltages across the resistances, so that this is called Kirchhoff voltage law. So in which the algebraic sum of the EMF, that is electromotive force, in a closed circuit is equal to algebraic sum of the voltages across the resistance in a closed circuit. Or simply we can say that the algebraic sum of the potential differences in a closed circuit is zero. So in which we are using one closed circuit, that is ABFE. This is one closed circuit. It contains one battery, three resistances R1 and R2 and R5. This is second closed circuit. This is B, C, D, F. It also contains three resistances R3, R4 and R2. When we apply Kirchhoff's second law to this ABFE closed circuit, algebraic sum of the EMF, that is only one battery is there, so that E is equal to algebraic sum of the potential difference across the resistance. You see here the current is I1, which is passing through the resistance R1 in clockwise direction. So according to the Ohm's law, the potential difference across the resistance R1 is I1 R1. And here the potential difference across resistance R2 is I2 R2. And potential difference across the resistance R5 is I5 R5. Here I1, I2 and I3 are in clockwise direction, so all of them may be taken as a positive. So from the Kirchhoff second law, E is equal to I1 R1 plus I2 R2 plus I5 R5. When the Kirchhoff second law will be applied to the BCDF second loop or second closed circuit, here there is no battery in the second closed circuit, so that E is equal to potential difference across the resistances. Here is I3 R3, here is I4 R4, here is I2 R2. I3 and I4 in clockwise direction, but I2 is in anti-clockwise direction. So I2 R2 may be taken as minus, and I3 R3 and I4 R4 is taken as positive. So that from the Kirchhoff second law, that is 0 is equal to, because there is no battery in the second closed loop, I3 R3 plus I4 R4 minus I2 R2. So this is the application of the Kirchhoff second law to the closed circuits. Now we will see about the mesh current method. By using this mesh current method, we can determine the unknown currents which is flowing in a closed circuit or maybe closed loops in a network. Of course, Kirchhoff's second law is also used for the measurement of currents in a closed circuit, but for the complicated circuits, we can use this mesh current method or maybe loop current method. In mesh current method, we will draw a number of equations, voltage equations, by using the Kirchhoff second law. For example, there is a 3 loops in a circuit network. There is a 3 equations we may write. So by using 3 equations, we can measure or we can calculate currents in that 3 currents in that 3 closed circuits. So these solutions, the solutions of these equations are the required values of current in a network. You see here, this is the 2 closed circuits or closed meshes are there. One is, this is a mesh 1, and this is mesh 2. In the mesh 1, there is only one current source. There is no current source in the mesh 2. Due to this current source, the current I1 which is passing through the resistance R1 and I2 which is passing through the resistance R4, because it is a junction in which the current I1 is split into 2 parts. One part is I2 which is passing through the resistance R4 and the remaining current I1 minus I2 which is passing through the resistance R2. This I2 is the same, is passing through the resistance R5 and this I1 minus I2 and I2 is entered at point B. So the sum of the total currents is I again which is passing through the resistance R3 and entered into the negative terminal of the battery. So these are the current components in the 2 meshes 1 and 2. Now when we apply Kirchhoff's second law to the mesh 1, in this mesh 1 there is only one battery, that is E is the EMF, so that is E is equal to, we know by using the Ohm's law, potential difference across the resistance R1 is I1 R1 and across the resistance R2 is I1 minus I2 into R2 and across the resistance R3 is I1 R3. By using the Ohm's law, V is equal to IR, where I1 and I1 minus I2 and I1 are in the same direction, that is clockwise direction. So all of them may be taken as positive. So that E is equal to I1 R1 plus I1 minus I2 into R2 plus I1 R3. Of course, here I1 is taken as common, that is E is equal to I1 into I1 plus R1 plus R2 plus R3 and minus I2 R2. This may be equation as 1. When we apply Kirchhoff's second law to the second mesh, in the second mesh, there is no battery, so that EMF is 0. That is 0 is equal to potential difference across the resistance R4 is I2 R4. And here across the resistance R5 is I2 R5. Across the resistance R2 is I1 minus I2 into R2. When you see here I2 and I2, then resistance across the resistance R4 and R5 in the same direction, clockwise direction, so it may be taken as a positive. So I2 R4 plus I2 R5 minus, because I1 minus I2 in the anti-clockwise direction in mesh 2. So that minus I1 minus I2 into R2. Here also, only one I minus I1 R2 is there. Remaining 3 I2 terms are there. From simplification, minus I1 R2 plus I2 into R2 plus R4 plus R5. This may be equation as 2. This equation 1 and from these 2 equations 1 and 2, we can simply write E is equal to I1 R11 plus I2 R12. Here R11 is equal to R1 plus R2 plus R3. This is in mesh 1. R1, R2, R3 are there. So that R11 is called index, that is impedance of the mesh 1. From the second equation, we made this 0 is equal to I1 R21 plus I2 R22. Here R22 is called impedance of the mesh 2. Here R12 and R21 are there, where R12 is equal to minus R2 and R21 is equal to minus R2. This R12 and R21 are mutual impedances of the meshes 1 and 2 respectively. So this is the application of mesh current method. By solving these equations 3 and 4, we can calculate current I1 and I2. So this is only example applicable to the two meshes only. The same theorem we can apply to n number of loops and n number of sources also. For example, let us consider there is n loops or n meshes having two power sources in two loops. Now, how can we apply this mesh current method to these n loops? Where I1, I2, I3, I4, and IN are currents flowing in a network containing sources E1 and E2 in first two arms. Then how can we write the same above equations when you applied here? That is E1, that is for the first mesh, is equal to I1 R11 plus I2 R12 plus I3 R13 plus and so on IN R1N. For the second mesh, we know E2 is the power source or maybe voltage source in the second mesh. So E2 is equal to I1 R21 plus I2 R22 plus I3 R23 plus and so on IN R2N. We know in the second, third mesh, there is no power source or voltage source. That is 0 is equal to same equation. And the remaining loops does not containing any power sources, all containing 0 voltages. By these n equations, when we solve, we can measure the currents I1, I2, I3, R4, and so on, IN. Where R11, R22, R33, and so on, RN and R impedances of loops 1, 2, 3, 4, and so on, IN. Here there is a remaining terms R12, R13, R14, R15, R1N, R21, R23, R24, etc. called mutual impedances. For example, when it is taken as Rij, this is a mutual impedance of the two meshes I and J. So this is the method to apply mesh current method for the n loops also. The solutions of above equations are the calculations of the values of required currents I1, I2, I3, I4, and so on, IN. Thank you.